Welcome. We're going to talk about error when you are performing hypothesis tests. Anytime you perform a hypothesis test and you make a conclusion, there's always the potential that your conclusion is wrong. Remember, there's two options. You either find evidence because there's actually evidence, or you find evidence just randomly by chance alone. And so, what we're going to do is determine what the different types of error are and what that means. When do you commit a type 1 error? When do you commit a type 2 error? What are the consequences of that, and how does that look? For this question, we have the Wolverine Worldwide, which is a shoe company in Rockford, that are improperly disposing of chemicals that have leaked into the groundwater. The state drinking water limit is 70 parts per million in order to be safe, and anything above that is considered dangerous. Officials believe that the water might be unsafe, and so they're going to take a random sample of 200 households, and they find an average lead level in the sample is 70.5. So we're going to start off by stating an appropriate hypothesis, and then making a conclusion, and then based on that conclusion, what are the possibilities for the errors that we could have made? So first of all, I want to underline a few things. Now, we have that the state's drinking water limit is 70 parts per million. The state's drinking water limit of 70 parts per million is what's considered safe. That's the thing that we're going to be assuming to be true. That's our null hypothesis. And then we have anything above 70 is considered dangerous. That's going to be our alternative hypothesis, because officials believe that the water might be unsafe, and unsafe corresponds to above. And then we have that they take a random sample of 200 households with an average lead level, and it says average. So what kind of problem is that? It's not percents, it's averages, which is means. So when we go to state an appropriate null and alternative hypotheses, we're talking about means, and the parameter for means is mu. And whenever we write our null hypothesis, we have an equality statement, and then our alternative is based on the claim that we're testing, where they're saying above, and the value that we're considering is 70. So we have the average is currently assumed to be 70. It could be less, but we're assuming equal. And then anything above that would help us with our claim. And so what these are saying in the first one, the null is that the water is safe. And the alternative is that the water is unsafe. Now, if we're doing the four-step process, of course, we're identifying our parameter. We're doing all sorts of things here, but right now we're just kind of talking about what our alternative and our claim is, and we're going from there. We're going to test, it's not given, but we're going to use that standard 5% level, or alpha equals 0.05. Now, after conducting a significance test, the p-value of 0.045 is found, and we want to interpret this value. And remember, the p-value is the probability that by chance alone we obtained the sample data that we did, assuming that the null was true. So we say, assuming that the water is safe, or that the null is true, there's a 0.045% chance or probability of getting the data that we did, the sample data that we did, which was that we had 70.5 average, just by chance. And the null is true, and this is obtaining sample data. I'm putting the two things in parentheses because these are the standard regardless of the problem. We're obtaining the sample data, but I gave it to you in context about the 70.5. We're talking about that the water is safe. So based on the p-value, should Rockford keep the current water or switch to bottled water? So it's asking us to make a conclusion. And the way that we make our conclusion is we look at the threshold that we've decided, our level of significance, and we compare it to our p-value. So the question is, how does our p-value compare to our level of significance? Remember that if our p-value is low, the probability of obtaining the data purely by chance is very, very small, which means we have evidence that the water is unsafe. If the probability or a p-value is high, this means that we could have obtained this by chance alone a good amount of time, and there is not evidence. Based on our p-value of 0.045 and our alpha level of 0.05, our p-value is less than 0.05. So because our probability is less than the threshold that we've decided to be our marker for evidence, we have evidence. The probability that it happened by chance alone is very small in comparison to the level that we've decided we want for evidence. So we have evidence that the water is unsafe, and so we should switch to bottled water. One more time. Because our p-value is small, this means the probability that we obtained that sample mean purely by chance, assuming that the water was actually safe, is very small, and so that's evidence that the water is actually unsafe. So if we made the wrong decision, what would be a consequence of this error? Well, if we're all switching to bottled water, that's going to cost money, and so this is going to waste money and resources on bottled water. This type of error, when we make a wrong decision, so suppose the decision is wrong, this type of error is a type 1 error. And the error would be, we said that we should switch to bottled water when we shouldn't, so we were saying the water is unsafe when the water was actually safe. And so in this case, the null was not false, it was true. If the water was safe, this would happen how often? Well, we have that threshold that we've decided, our alpha equals 0.05 level of significance. So this would be how often that could happen. There is a 5% chance that we could commit this error. So 5% of the time, we get a statistically significant result purely by chance. Statistically significant means that we have evidence. So a type 1 error is your alpha percentage. It's the willingness that you are to commit an error, or how often you could possibly have an error if the null was actually true based on our level of significance. So now suppose that the p-value was 0.14. Should the town keep the current water or switch? So again, we compare, how does your p-value compare to your level of significance? So 0.14 versus 0.05, or 14 hundredths versus 5 hundredths, 14 hundredths is more than 5 hundredths, which means that the probability of obtaining those values purely by chance is more than our level of significance, which means that it happens by chance more than we're willing to accept. And so we should not switch to bottled water. We should keep the current water because we don't have convincing evidence. So what if we made a wrong decision? What would be a consequence of this error? Well, in this case, if we're keeping the water and this is wrong, this means that the water is unsafe and you could possibly get sick or die. This mistake is a type 2 error. So are the consequences in question 12 or 15 more serious? So is it more serious for you to waste money and resources, or is it more serious for somebody to get sick and possibly die? I believe that causing a human harm, possibly killing them, is much worse than wasting money. These are the types of error that you can make and what it looks like to talk about the consequences. Now, type 1 and type 2 errors are probability statements. They're conditional probability statements. So I'm going to put together a chart for you to show you about type 1 and type 2 error. Okay, here's our chart. If the null is true, but we reject it, this is an error, and this is our type 1 error, which we have labeled as alpha. That is the probability that we are willing to commit a type 1 error. However, if the null is false and we reject it, that's the correct decision. That's what you're supposed to do. If the null is true and we fail to reject it, that's also the correct decision. If the null is false and we fail to reject it, that is a type 2 error. which we use beta to represent the probability of committing a type 2 error. One other thing, we don't really talk about it in this class, but 1 minus beta is the power, which is the probability of correctly rejecting the null. That is you doing the right job in your hypothesis test. What is the probability that you are correctly rejecting the null? So like I said, these are conditional probability statements. The probability that you reject the null, given that the null is true, is your alpha, which is your type 1 error probability. How willing are you to commit that type 1 error? The probability that you fail to reject the null, given that the null is false, is beta, which is the type 2 error probability. And then the probability of correctly rejecting the null is your power. I'm not going to ask you to calculate power on the test, and I won't necessarily ask you to calculate the probability of committing a type 2 error in terms of beta. You will always either be given alpha or you'll decide alpha is 0.05, but essentially you will be asked what type of error could you have made and what's the consequence of that error. Okay? So if you rejected the null, you could have done so incorrectly. If you failed to reject the null, you could have done so incorrectly. And what are some consequences of that? Thanks for watching.